Hello and welcome to Off Chain. Today we have a very special guest, John Newbery, core developer, a very prolific core developer, as a matter of fact. And we are going to have a discussion on some of the articles that he's written about 0.15.0. And yeah, I just want to welcome John Newbery. Let me see. Okay, did I bring you in right? Yes. Okay, you're going to have to unmute yourself. Hey, John.
Okay. Hi, Jimmy.
I mean, you have been doing a lot of stuff. Can you tell us a little bit about where you work and what you do?
Yeah, I work for a small company in New York called Chaincode Labs, and we're focused on cryptocurrencies, specifically Bitcoin, and the five of us here on the whole contribute to Bitcoin Core and try and strengthen the community and strengthen the Bitcoin ecosystem that way.
Okay, great. Let's start off with something that I try to ask all my guests on the show. How did you hear about Bitcoin, and what was that like? What was it like when you first heard about it? What was your reaction?
Yeah, I think I'd probably heard about Bitcoin in 2011-ish. A friend of mine told me about this interesting new technology. I took a look at it and I thought, if someone on the other side of the world buys a cup of coffee, my computer needs to validate their signature. Seems a bit weird. And I thought, this doesn't scale. This looks like some toy for geeks. And I got on with my life and ignored it. And didn't really think about Bitcoin much for the next few years until probably 2015, when I started hearing about it a bit more, and I looked into it and got hooked and was fascinated and discovered payment channels and Lightning Network. And I thought, maybe this thing can scale. Maybe we can do something interesting with it.
So it was actually Lightning Network and payment channels that got you interested back into Bitcoin because you saw that as a scaling solution?
Yeah, I mean, blockchains in their current form don't really scale. And these layer 2 technologies made me think, actually, we can do something interesting. This technology can scale, and we can use it to service a lot of people around the world and make something interesting.
Okay. And you've obviously been a very prolific core developer. Can you tell us a little bit about how you got into core development? Like, what was the process?
Yeah, I was working on something completely unrelated to Bitcoin in 2015, and I rediscovered Bitcoin and got hooked and went down that rabbit hole and read everything I could read and listened to podcasts, checked out the code. And eventually, after 18 months or so, I decided it was time to quit my job and focus on Bitcoin. And around the time I did that, Matt Corallo tweeted that he was doing a month-long residency program in New York, which I applied to and was accepted to, and I did that. And at the end of that month-long program, the guys at Chaincode asked if I would come and work full-time. So
wow,
that's how I got here. Yeah.
Wow. Can you tell us a little bit more about that 1 month long, I guess, training program at Chaincode? What was that like? What did you actually learn?
It was amazing. It was run by Matt Corallo, who is one of the longest-standing Bitcoin Core developers, and he really wanted to instill in us a sense of the security aspects of Bitcoin, security trade-offs, and the security models, and what are things like proof of stake and proof of work and selfish mining. What do these all mean for the network? So it was amazing to get to talk to him and to talk to Alex and Suhas, who run Chaincode here and also very prolific core contributors. There were four of us, 4 students, and it was just a great experience to sit with these people and talk about these fascinating ideas and actually get to work on the code.
And are there plans to do that again? What's the? I mean, it sounded like a great experience and a great way for people to get into core development.
Yeah, I mean, I would love to be involved in doing it again. We don't have any firm plans yet, but watch this space. We may do it again.
Yeah, so guys, you need to follow John. He's on JF Newbery on Twitter, and he definitely requires a follow, not just for this potential training for a month, but also because he writes a lot of great articles, which is something that I want to talk about. You've been talking a lot about 0.15.0 and all the different sort of interesting features that are coming into it, and it's very easy as sort of a community to just see an upgrade and be like, I have to upgrade again, and what am I getting out of this? I think you've done a great job just sort of like making the case that core developers are actively making Bitcoin Core better by adding these features that sort of optimize a lot of things that aren't necessarily easy to see. So can we talk about that a little bit? Let's start with the first article that you wrote about per output chain state DB. What is that exactly?
Okay, what we're interested in Bitcoin when your node is running is the set of unspent transaction outputs. The blockchain is just a log of what's happened on the network up to that point. What we really need to know is what are the unspent transaction outputs. And when you see a new transaction, is it spending a legitimate output, and is its signature correct? So the chain state DB, the chain state database, is a collection of all of those unspent transaction outputs.
Okay. And
sorry.
Yeah. So the chain state DB is all these outputs, the UTXOs, and it sort of has a database of those. Well, what's the exact improvement in 0.15?
Well, before 0.15, that database was structured per transaction. So the main entry in that database would be a list of the outputs from a transaction. The change in 15 is that it's now structured per transaction output. So the reason it was originally structured per transaction was that saved on space, right? So if you have a transaction with 5 outputs, you would just store that as a list, and you'd only need to store the transaction ID once for that entire list. Now you store each transaction output with the transaction ID attached to that output. So it's a slightly different way to structure the database. It takes up a little bit more space, but it's got a whole range of benefits, mostly to do with memory usage of the database. About a month ago, there was a conference in Paris called Breaking Bitcoin, where someone spoke about a potential attack on Bitcoin, where you could craft a transaction that took some inputs, and because those inputs were from transactions with lots of outputs, it would cause the memory on your node to blow up. This fixes that problem because the memory usage is a lot more smooth, it's a lot more predictable, and along with that, we have a whole range of benefits from just having a more controllable memory usage for the database.
And how long has this been sort of in the pipeline? Who sort of wanted to do it, and why was it done?
It was implemented by Peter Willer. It's been wanted for quite a while, I think. I don't know the exact history, but it was implemented a few months ago. Went through a lot of review because it's quite a large change to a consensus critical part of the code. I think it's something that's been wanted for a while, but Peter finally implemented it.
Okay. And how does the initial block download speed up as a result of this change?
Well, one of the largest time factors in the initial block download is flushing this database to disk. So as your node catches up with the tip of the blockchain, you're getting more and more transactions, more and more transaction outputs, and this database is increasing in size. And before you run out of memory, your node will flush it to disk, and it'll keep doing that periodically as you move forward through the blockchain. Because we now have a much more predictable usage of memory, we don't need to do that flush so frequently during IBD, and that consequently makes IBD a lot quicker.
So the major part of IBD that takes so long is actually writing to disk sort of on a sporadic basis, but if you do it in sort of one continuous write, it's a lot faster. Is that right?
Yeah, it's one of the factors that makes IBD slow is that we need to flush this database to disk quite frequently and less frequently now in 0.15.
I see. I see. And how was it was interesting to see sort of the evolution of the blockchain database, because what you had written in your article is that at one point it was just entire blocks were just stored and you had to go look up each one, and then sort of a per transaction thing was put into the chain state database, and now it's sort of on a per output basis. Are there any more sort of optimizations that we could do on this, on the chain state database to make it even faster, or are we sort of at its limit already?
This seems conceptually to be at its limit, but there are very, very smart people working in Bitcoin, and who knows what people come up with next. Sure.
Okay, and let's talk about fee estimation, because this is something that a lot of people have been talking a lot about over the past few years, right? Like, how do we decide the fee? What is it about fee estimation that's so complex? Why is it so difficult to get right?
Well, it's because we're basically trying to talk about future events in a dynamic system based on our incomplete knowledge of the past, right? So we're a node, we see transactions come into the mempool, we see blocks come in, and we're trying to make a prediction about what the transactions will look like in the future. That's quite difficult, and it's a dynamic system, so what some people do affects what other people do on the system. There's just a lot of moving parts.
Yeah, so it's a complex nonlinear system, and that's kind of what makes it hard, because you only have past data and you don't necessarily have that much current data to be able to figure out what a miner will take. Reading the article, there's this sort of concept of buckets and targets. You've written 2 articles on fee estimation just on that. So can you describe what buckets and targets are and why they're important to figure out what the fee should be?
Yes, so talking now about Bitcoin Core's implementation of fee estimation. Bitcoin Core does not try to be too smart and does not try to be too forward-looking. It simply looks at statistics of the past and tries to give the user some sense of how many blocks they might have to wait if they attach a certain fee. So the 2 concepts you mentioned, buckets and targets. Bitcoin Core is looking at transactions as they come into the mempool, but it doesn't keep track of every single fee attached to every single transaction. That would be a lot of data for it to process. So it groups them together, groups the fee rates into ranges, which we call buckets. And so the first bucket would be from 1 Satoshi per kilobyte to 1.05 Satoshis per kilobyte, sorry, per byte. So that's what a bucket is. That's one axis of a matrix of transactions that we're storing. And the second axis is targets, and that's how long we are expecting a transaction to take to confirm in a block, or how long we're prepared to wait for a transaction to confirm in a block. So Bitcoin Core is keeping track of this two-dimensional matrix and using that to give you an estimate for how much fee you need to attach in order to be confirmed within a certain number of blocks.
I see. And how do mempool evictions sort of change the fee estimation? Because that's a sort of a main feature of the 0.15 improvement.
It's one feature, yeah. So 0.15, I'd say, is a grab bag of different improvements to fee estimation. It keeps the same framework, but it makes it perform better under a variety of circumstances. And one improvement that was made was previously transactions that entered your mempool, which were then evicted because their fee was, your mempool filled up and their fee was at the lower end, and so they get evicted first. Those transactions were not properly accounted in the fee estimate, in the fee estimation algorithm. So small change there, account for those properly, and hopefully the fee estimation algorithm now gives a better answer for how much fee to attach.
I see. So the mempool bumping sort of helps account for transactions that sort of never made it. Okay. Let's talk a little bit about replace by fee, because I don't think this is something that a lot of people actually understand, like what works and how transactions get into blocks based on, like whether or not you can bump a fee and things like that. Can you describe the feature first of all? What is replace by fee?
So if you create a transaction and broadcast it to the network, and it turns out that you haven't attached enough fee to that transaction for it to be confirmed, you're basically stuck. Your transaction is in people's mempools across the network, and it will stay there in this limbo state until it gets aged out, maybe a week later. Now, there's two ways to fix that. You can either do child pays for parent or replace by fee. Shall I explain both of those? Or?
Yeah, sure.
Okay, so child pays for parent is where you take your stuck transaction and you spend one or more of its outputs on a child transaction, and you attach a lot of fee to that child, so much fee that it can pay for itself and its parent to be included in the next block. That's one way to unstick your transaction. The other way is replace by fee, which is where you take your start transaction and you recreate it, you re-sign it, but you just attach a bit more fee to it. And hopefully your additional fee will be enough for it to be included in a block.
And what's the change in 0.15 that we saw?
So replace by fee was opt-in replace by fee was made into a bit 125, and I think bumpable transactions or replaceable transactions were implemented in fee 0.12, I believe, and then bump fee, which is where you can actually replace them, was implemented in 14. But until now, those were just available on the command line, so you needed to use the RPCs. 15 takes that functionality and puts it in the GUI, so it's now available to anyone who uses the Bitcoin QT GUI.
Are there other wallets that actually implemented replace by fee, or is the core wallet the first?
I believe other wallets do it. I'm not sure. Jimmy, do you know?
I actually don't know. I don't know. That's why I'm asking you. But yeah, it would be interesting to find out, because it's a feature that looks very useful, especially if you send a transaction and realize, okay, oh, I need to get this in quicker, and you can increase the fee and things like that. One of the great mysteries, of course, is that Bitcoin Cash removed this feature as part of their fork. Any clue as to why they did that?
They have a very different vision for Bitcoin than I do, Jimmy. I don't want to be too rude about them, but they don't believe that there should be fees, or that fees should be minimal. And there is some movement against replace by fee because you can't trust zero-conf transactions, but you should never trust zero-conf transactions if they're not confirmed. They're not good. Yeah. So different vision, different philosophy about Bitcoin.
I see. Okay, let's talk then about multi-wallet. What is this feature, and how does it change the core wallet?
Multi-wallet is where, well, it's exactly what it sounds like. You can have more than one wallet running on your Bitcoin core node at any one time.
Previously, you only had one wallet, is that right?
Yeah, so previously Bitcoin Core could only be running one wallet at any time. You could stop your node and then start up with a different wallet, but at any one time there would only be one wallet running.
Okay, and how's that different than sort of HD wallet accounts? Because that's sort of like a part of BIP44, and that's supposed to give you the functionality of multiple wallets, but sort of in a single seed.
Right. So HD wallets are where you have a single seed, like you say, and from that you can derive a whole tree of different private keys, different addresses. But those are all connected somehow logically within your wallet. When you create a new transaction, you can take inputs which have been sent to multiple of those keys and combine them to create a new transaction. So at a conceptual level, there's some kind of linking between all of the addresses in that HD wallet. Multi-wallet, on the other hand, is where you have two completely separated wallets. So you can't create a transaction that takes inputs from both. You have a balance on one wallet, which will only be the transactions in that wallet, and a balance on the second wallet. And the idea is to have completely separated, I'm going to use the word accounts, but that's kind of problematic because accounts are used elsewhere, but completely separated wallets. So you might have, for example, a personal wallet and a business wallet if you have some business that transacts in Bitcoin and you need to keep them separate for tax purposes or accounting purposes. They're just completely separated.
That makes sense. And let's move on to script caching. This is an optimization by Matt Corallo. Can you describe what this does differently than before?
Yeah, so the majority of transactions that you see in a blockchain, if you have a synced running full node, you'll see them twice. You'll see them once when they enter the mempool, when they're broadcast by whoever created that transaction, and then again when they're included in a block. And in the early versions of Bitcoin, when you saw the transaction come in the first time, you'd validate it, and when you see it come in block, you'd validate it again. That's obviously a waste of computational time because you're doing the same activity twice. So the first optimization there was to cache the signature validation. Signature validation is the most expensive part of validating a transaction. And that went in a few years ago. And what Matt did was extend that. So instead of just caching the output from the signature validation, it caches the output from the entire script of the transaction input. So that, again, is a big optimization. It means that when you receive a block with transactions that you've already seen, you don't have to then go back and reevaluate all of those scripts in the transaction inputs.
And that helps with the throughput of the blocks, and you don't have to, if you have like a multi-sig transaction, for example, instead of having three separate signature cache hits, you just have a single cache hit for the entire script.
Yeah, that would be right.
Okay, well, good stuff. Obviously, there's a lot of even more things than this that got in, including your own, test suite, that got revamped quite significantly in 0.15. Do you want to speak about that a little bit? How the entire Python test framework changed with some of the stuff that you did?
Yeah, so I got into this project, started opening pull requests a year ago, and I had a lot more experience with Python than C++, so I started working on the test framework that's written in Python. And what I was trying to do was really improve the test coverage, make the test run faster so people wouldn't have to wait as long when they're iterating through changes. And so one of the things I've been trying to do is revamp that test framework so it's more self-contained, it's easier for the other developers to write tests in that framework, it's faster, all of the utilities are much easier to access. And if your listeners are interested, they can go on, and I'm very happy to help new contributors and show people what I've been doing in there.
Yeah, which is something that actually David Harding asked earlier today, which is what can sort of non-developers do to contribute to Bitcoin Core? What are some sort of possible ways in which they can help out?
I think the first thing people can do to help is just to be informed and be educated. There's so much drama going around and uninformed opinion being thrown around, emotive attacks by one party or the other. I think if people who care about Bitcoin inform themselves and are able to make informed decisions, I think that's really helpful for the community as a whole. It helps the environment around Bitcoin. In terms of contributing to Bitcoin Core, there's translation work that needs to be done. People can help test and file issues run the latest code and test it, and there's documentation work that can be done. There's always we can always do a better documentation. There's a lot of ways that people can get involved.
Okay, what's your opinion on Bitcoin Cash? Like, now that it exists, do you believe that the 2x hard fork is still required? This is a question from David Poole on Twitter, by the way.
Okay. I don't think I've ever believed, no, I'll state certainly I've never believed that the 2x fork is required, and I think it's quite dangerous and divisive. It's a good question. Big blockers now have their big blocks in Bitcoin Cash, and people who don't want big blocks have Bitcoin. I prefer not to see a hard fork. I think it will divide further Bitcoin, but we'll see what happens.
And this is a question from our chat. What do you think about China's possible ban? They're talking about, executives of these exchanges can't leave the country. They're talking about possibly banning even mining. What sort of effects might that have on the ecosystem?
Jimmy, I don't know. That's a very good question. Nobody knows. If all of the mining power in China got switched off, obviously that would have some major impact on blocks. We'd have slow blocks for quite a few weeks. Yeah, who knows what's going to happen? I certainly can't give you any answers.
What would you do as sort of a core developer? What sort of pull requests would you add to, I don't know, mitigate that problem? Is there anything that we can do as developers or as a community or anything to alleviate maybe like a lack of hashing power coming from China?
You mean, you're referring to something similar to the EDA in Bitcoin Cash? Like some change in the difficulty?
Yeah. Is there anything we could do? Is there can we hard fork to a better, changing it so that the 2 weeks come up faster or something like that? What could we do?
Any change to the difficulty algorithm I've seen, the cure is usually worse than the disease. it makes difficulty gameable. On top of that, what you're talking about would be rushed. It would be divisive. You wouldn't get consensus. You wouldn't get people on board. No, I don't think that's a starter, really. It's interesting to think about, but any change, like any hard fork change, I would want to see many months of groundwork and consensus building. I don't think a knee-jerk reaction to some event would result in a good hard fork.
So what do you think are some challenges coming up? How do you see things sort of come? What are some things that you see coming up for Bitcoin Core that might be interesting for our viewers to see?
Well, there's lots of good stuff in 16 coming along. I always love listening to people like Peter Willer and Andrew Postra and Greg Maxwell talk about what they're working on. There's lots of really interesting things. MAST, UTXO commitments, signature aggregation, script scripts. There's so much cool, fun tech coming along. We'll see what happens in November around 2x. That'll be interesting.
What are you personally excited about? What are you personally excited about the most?
Really excited about Lightning and seeing that roll out, seeing actual use cases of Lightning, people putting money on the line. I'm excited about MAST. I'm excited about signature aggregation, Schnorr, Belen, Nevin.
Can you talk about MAST a little bit? That's been sort of going around dev circles, but I'm not sure sort of the general Bitcoin community is aware of what it is and what that's about.
Well, there are several proposals for how to do it, but the basic concept is in your in your script, you basically structure your output script pub key like a Merkle tree. And when you spend from that Merkle tree, you give a proof down to the branch of that Merkle tree, and then you give the spending script. So it means that when you create the when you create a spend, and when you spend it, you're not revealing all of the other branches of that Merkle tree. That's kind of a high level overview of what it is. I mean, it allows interesting constructions, and who knows what people will use it for.
Is it more for privacy, or is it for blockchain size efficiency?
It's certainly good for privacy and fungibility, and there may be scaling benefits to it as well. That's not something I've really looked into that much, but I find the privacy and fungibility side of it interesting.
Okay, and when do you think Lightning stuff will be incorporated more into Core? Because I know it's much more sort of with the Lightning Labs people. Are there plans for, or is anyone working on sort of, incorporating Lightning into the Core client?
Not to my knowledge, no. I don't think that's I don't think that's a name for any of the developers, not that I know of. So there's a few Lightning implementations. There's the Lightning Labs one that you mentioned. Blockstream has their own implementation, which is worked on by Rusty and Christian, also open source and available for people to download and play with. And then there's another implementation called Eclair, out of a group in France. So it'd be really exciting to see those roll out and people start using those, and hopefully then being able to talk to each other.
Are they all compatible, I guess, then?
That's the aim, yeah. And there was some work in San Francisco and Paris in the last month where the teams got together and worked on compatibility.
Okay. Oh, that is great. Okay, so I think we're kind of running out of time, and I think we're almost out. But where can people find you? Where can people sort of read your stuff and things like that?
My Twitter handle is JF Newbery. That's Newbery. That'll link to my Medium, where I write occasionally some technical pieces on Medium. On GitHub, I'm JNewbery without the F, so you can follow me there if you want to see what I'm doing there. IRC JNewbery. Yeah. Okay,
great, thank you. Yeah, I want to remind our listeners that, or viewers, I guess, that we are. I am still running Programming Blockchain. I'm going to have a seminar in LA on October 12th and 13th. I'm also doing one in the Bay Area, October 31st and 1st, right before Scaling Bitcoin, which John will also be a part of. So yeah, sign up for that if you are interested in becoming a Bitcoin developer. John's obviously followed that path from just going to a developer to a Bitcoin core developer, who's obviously very prolific. So I want to thank John for being here. And that will be all for today. And that is the end of the song. Thank you.
Thanks, Jimmy. It's been fun.